Hi, welcome to today's talk on kinematic equations with constant acceleration. What are we learning? We're going to look at the kinematic equations for one-dimensional motion with constant acceleration, meaning we're going to look at the relationship between displacement, final velocity, initial velocity, acceleration, and time. Our essential question is this: what are the mathematical relationships for displacement, final velocity, initial velocity, acceleration, and time when the acceleration is constant? So here are the variables that we know about so far. We know displacement, initial velocity, final velocity, acceleration, and time. Now I put these other symbols down here too because you may see initial velocity written as v sub 1, or v sub 0, or v sub naught. You may see final velocity written as v sub 2, or just v. Let's start by looking at one-dimensional motion with constant acceleration by looking at our acceleration, which is the change in velocity over the change in time. If we expand delta v to mean v final minus v initial, we have this equation, which we are going to solve for the final velocity. The final velocity then is equal to the initial velocity plus acceleration times time. This actually is our first kinematic equation. To get our second kinematic equation, we have to remember that the area underneath the velocity versus time graph is displacement. Now, if we look at the area of this triangle, the area of a triangle is 1/2 base times height. Our base is time. Our height is our change in velocity. Acceleration is delta v over delta t. Solving it for delta v, we see that delta v is at. So this height becomes at. If we take at and plug it into height, multiply it by time, we get area being 1/2 acceleration times time. We add all of this area together, the triangle plus the rectangle, and we get displacement. Displacement is v sub 0 t, which is the area of the rectangle, plus 1/2 at squared, the area of the triangle. So we'll have the big three kinematic equations. So far, to find out how fast we're going while at constant acceleration, knowing the initial velocity and the time, here's our relationship. The final velocity is the initial velocity plus acceleration times time. The second equation that we saw was the displacement being the initial velocity times time plus 1/2 acceleration times time squared. Of the equations that we know so far, let's see which of these equations has which one of our variables here. So our first equation, notice that it does not have displacement, but it has initial velocity, final velocity, acceleration, and time. The second equation does have displacement. It has initial velocity. It doesn't have final velocity, but it has acceleration times time. Now, I won't go through the derivation of this, but if you take and substitute time between these two equations, you get a third equation. The final velocity squared equals the initial velocity squared plus 2 times the acceleration times the displacement. Let's see which variables this one has. This one has the displacement. This one has the initial velocity. This one has the final velocity. This one has acceleration, but does not have time. Let's look at an example now. And this will show you how to become an expert physics problem solver. Once you read a problem that's been given to you, the first thing to do is to draw a really good picture of the situation with all of the variables labeled. So let's say I tell you that we have a car and it has constant acceleration. It goes for 2 seconds with an initial velocity of 10 meters per second. It has an acceleration of 5 meters per second, or 5 meters per second squared. And we want to know what is its displacement during those 2 seconds. So we list all the things that we know from our problem. We list what we're looking for. And now we find an equation that relates all of these variables together. Here's that equation. Here's we'll call this our how far equation for constant acceleration. The displacement is the initial velocity times time plus 1/2 acceleration times time squared. Let's double check that we have everything that we're looking for. Well, we're looking for the displacement. This equation is solved for the displacement. Do we have the initial velocity? Yes, we do. Do we have the time? Yes, we do. Do we have the acceleration? Yes, we do. And there's the time again. So at this point, we do our plug and chug. Just plug in all the quantities for the variables. So let's review the 3 equations that we know. First, we have the final velocity equal the initial velocity plus acceleration times time. This is the velocity as a function of time. Then we have how far it went, or its displacement, equals the initial velocity times time plus 1/2 acceleration times time squared. This is the displacement as a function of time. And finally, if we are not given time, we have an equation that gives us the velocity as a function of displacement. The final velocity squared equals the initial velocity squared plus 2 times acceleration times the change in position, or our displacement. All right, thanks for listening. Rewind and review as necessary. Don't forget your Cornell notes.